everybody. In this video, we're going to start talking about what an imaginary solution to a quadratic function is, okay? And that is a brand new topic in your world of math. You have probably never studied anything about imaginary numbers, and we're really going to do just a really brief introduction here. So I've got some examples to show you on how to break down some radicals as an introduction to imaginary numbers, and check out what's common here. Every single radicand underneath the square root is negative, and that is the key. The square root of a negative number is imaginary. And I don't mean imaginary like someone made it up in a mystical universe, but we have no numbers in our number system that can multiply together to give us a negative 25. If we use positive 5 times itself is positive 25. And if we use negative 5 times itself, that's also positive 25. So we have no real numbers that can multiply by themselves, which is what squaring is, to give us a negative value. So that's where the introduction of imaginary numbers come from. So I want to break it up like this. You guys, that square root of a negative could be broken up into negative 1 times the square root of a positive number. And here is our brand new thing. This is our brand new topic. We all know what the square root of 25 is. It's 5. But the square root of negative 1 is defined to be I. So my final simplification here, my final answer is 5I, imaginary 5. Make sure you jot that down. The square root of negative 1 is equal to a number called I. And I put a little tail on my I so it doesn't accidentally look like a 1. Okay, let's do that with negative 8. If I break this up into the square root of negative 1 times the square root of 8, the square root of 8 we have worked on so many times. I know that I need to simplify this. That's 2 times 4, and 4 is 2 times 2. So here's all my prime numbers. I'm looking for pairs. So I'm going to pull out a pair of 2s to write out front. And I'm going to leave anything unpaired on the inside. And now this square root of negative 1 is I. That's where the imaginary value comes from. And I slide it. Normally you're going to see it slid right in front of the square root symbol. That's normally where it sits in an answer. It's right in front of the square root symbol. Okay, let's go again. I'll break off the negative 1, and then we will simplify 110. Because anything that ends in a 0 can be divided by 10, and this is 10 times 11. 11 is prime. 10 can be broken into 2 times 5, and both of those are prime. So even though I simplified 110, I have no pairs to pull out, which means 110 is already simplified. However, the square root of a negative 1 is I, and it goes right in front of the square root symbol. Final example for you here. Separate this negative off, and you'll have the square root of negative 1 times the square root of 100. I bet we all know what the square root of 100 is. It's just 10, because 10 times 10 is 100. And the square root of negative 1 is I. So check out all these solutions. There's not much extra to learn here since we're just doing a brief introduction. What you need to know is that if you get a negative underneath your radical, you're going to have an imaginary solution. Now let's see what that looks like in our quadratic formula. This whole time we've been talking about a very special part of the formula called the discriminant. And the discriminant really is in charge of what types of solution and how many solutions we have. Okay, so this time I think you can already guess what our discriminant is going to be if we're going to come up with imaginary solutions. Our discriminants are going to be negative numbers. So let's get started on some examples. Get the formula on there. Okay, number 1 is not quite written in standard form. Well, I guess it kind of is, but you might want a placeholder here. There is no linear term in the B position, so I'm going to hold that place with a 0n so that I can clearly see what A, B, and C are. A is equal to -3, B is equal to 0, C is equal to -3. Time to plug in all of our values. -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. If I'm going too quickly at any point, just pause the video so you can jot things down correctly. I'm headed over to Desmos to figure out this discriminant. 0 squared minus 4 times -3 times -3 is -36. I hope you anticipated a negative here. -36 as our discriminant. Two times -3 is -6 in the denominator. Okay, so this is a pretty big deal. A negative in a discriminant tells me I'm going to have an I, or an imaginary solution. So we all know what the square root of 36 is. That's 6. But now that that 36 is negative, I need to include an I to represent an imaginary solution, 6i. Okay, so let's see. -0 plus 6i would be 6i over -6, which would be -1i. And -0 minus 6 would be -6i over -6, which would be +1i. So my two solutions are -i and +i. -1i and +1i. Pretty cool. You guys, had this turn out to be a +36, we would have been right back to where we were when we very first started the quadratic formula. We would have 2 real rational roots, but now we have 2 imaginary roots because the discriminant came out negative. All right, let's see a second example. First things first, I need to get this set up into standard form. So I'm going to add 2b across to put in the linear position, which makes a equal to 6, b equal to 2, and c equal to 6. Plug everything into the right spot on the formula. It says -b, so -2, plus or minus b squared, which would be 2 squared, minus 4 times 6 times 6. All over 2a, so all over 2 times 6. Moving over to Desmos. Let Desmos do my simplify for me. I've got -140. Negative is important. -140 as the discriminant value. And then 2 times 6 in the denominator is 12. So I know the negative is going to mean there's something imaginary happening. I got that part. I also have a 140, which is not a perfect square. I'm going to have to break that down, or at least try. So 140, that ends in a 0. That's 10 times 14. 10 is 2 times 5. 14 is 2 times 7. So it looks like I have a pair of 2's here. 2 times 2 times 5 times 7. And if I collect the pair of 2's as the outside number, I would have 5 times 7 left on the inside, which is 35. So let's simplify. That negative 2 didn't change. I've got 2 on the outside and an I on the outside to take care of the negative, and then 35 on the inside, all over 12. We're almost done. This is a toughie. You guys, all of these real numbers, the negative 2, the positive 2, and the 12 can be reduced by 2. So divide everything by 2. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1i. This 35 doesn't count because it's an irrational value. It's in a square root. 12 divided by 2 is 6. I'm going to make a note here. Reduce. So my final answer is here. Negative 1 plus or minus 1i times the square root of 35 all over 6. Now, the only part you do not have to write in that whole thing is the 1 times the I. We never have to write a 1 that's multiplying something, so I'm going to write it like this. Negative 1 plus or minus I, that is 1i, times 35, square root of 35, all over 6. You guys, I totally would not count it wrong if you left that 1 right there. Okay, my final example for this unit. Let's take a look. Of course, we're not in standard form. Hopefully, we're getting a lot of practice with that. I'm going to subtract this 8b and set it into the linear position. So b squared, 7 minus 8 is negative 1b plus 4. So the a value is positive 1, the b value is negative 1, the c value is 4. Put everything in the right position of the formula. Negative b would just be a positive 1 this time, plus or minus b squared minus 4 times a times c all over 2a. Decimus is going to help me solve the discriminant. I get a discriminant value of negative 15. Negative 15 beneath the radical. 1 plus or minus the square root of negative 15 all over 2 times 1 is 2. 15 is not a perfect square. If I go below to try to break down 15, it would only be 3 times 5, which has no pairs, so I can't simplify 15. So the only thing to take out of 15 is this negative value, which we know is going to come out as I. So we'll have 1 plus or minus, that negative is coming out as I, times the square root of 15 because it can't be simplified all over 2. Now let's look at our real values here. We have a 1, another 1, and a 2. I can't simplify that, so that is my final answer. 1 plus or minus I times the square root of 15 all over 2. So what are we noticing about the discriminant? I hope I've made it really, really, really clear. Every single time we have a negative value as the discriminant, our answer comes out imaginary. All discriminants are negative numbers. The very last thing I want to do here is show you what happens when you try to solve these type of equations by graphing. So I'm going to try and graph number 1. y equals negative 3x squared plus 0x minus 3. Now, I didn't do anything wrong here. What you notice is that the function does not hit the x-axis. Remember, solutions to a quadratic live at the x-intercepts, and this has no x-intercepts. So we would say it has no solution, but really it just has no real solution. It does have imaginary solutions. Let's check out example number 2. Y equals 6x squared plus 2x plus 6. There it is. Look at that parabola again. It does not hit the x-axis. So we would say that has no real solutions. And now we know how to find the 2 imaginary solutions. Whoops. Finally, let's check out number 3. Y equals x squared minus 1x plus 4. And we have the same thing happening again. The parabola never touches the x-axis. So we would not be able to solve these type of quadratic equations by factoring or by graphing. We have to be proficient with the quadratic formula in order to solve these type of problems. I'm going to give a little sketch here as to what that looked like. The parabola never touches the x-axis. No x-intercepts. Got a little messy there, sorry. No x-intercepts. Okay, guys, practice, practice, practice. Let me know if you need any help, and happy studying.